Welcome back. We're still learning about triangles, and today we're talking about something we call the triangle inequality theorem, which sounds really fancy, but it's actually quite simple, and even better, it makes sense. What it says is the sum of the lengths of any two sides of a triangle must be greater than the length of the third side. Let me show you what that means. So here I have some triangle sides, right? And I can make a triangle with these because these two shorter sides, if I added the sides together, they would be bigger than the third side. See where they overlap? That overlap is really important. That's the greater than part of adding them together. Because look at, see, I can move them up and connect them. If they don't overlap, if I add them together and they're not bigger than the third side, I can never make a triangle with them. That's what that means. So our first couple questions are asking, is it possible to form a triangle with the given side lengths? If not, explain why not. So what we're going to do is, let me zoom in. We're going to look at the smaller ones, look at the two smaller sides, add them together. So 3 plus 4 equals 7. Is 7 greater than the third side? Yeah, okay. That one will work. This one is 6, 9, and 15. So let's take the two smaller sides. 6 plus 9 equals 15. Is 15 greater than 15? No. It can't be equal to. It has to be greater than. There has to be a little bit of overlap for this to work. So we would say no, because 15 equals 15. Okay, so that one's a no-go. Let's try 8, 8, and 8. They're all the same length, so we can just take two of them. 8 plus 8 equals 16, which is greater than the third side, so that one's good to go. And this one, 4 and 8, those are the two small ones. 4 plus 8 equals 12. That's not going to work because 12 is less than 16. So that one's a no-go. This next part says, find the range for the measure of the third side of a triangle given the measures of the other two sides. So first, anytime you're given some sides of a triangle, draw a picture. Then we're going to set up some different equations and see what happens. So the first one, there's already a triangle drawn for you. And we're working with this triangle that has sides 1, 6, and x. So what we want to know is, what can x be? Well, we're going to take the sides that we're given, 6 and 1. First thing we're going to do is find the difference. So 6 minus 1 is 5. Then we're going to find the sum. 6 plus 1 equals 7. So these become our boundaries. X has to be between 5 and 7. So in this case, that's just 6. I think that's our only option. But let's double check and make sure that 6 works. So now we have three sides, 1, 6, and 6. So again, we'll take two of them, add them together. So 1 plus 6 equals 7, which is greater than the third side. So we're good to go. Let's try this one. We've got a triangle with 12 yards and 18 yards. Let's write those numbers in, 12 and 18. So first we'll find the difference. So 18 minus 12 equals 6. Then we can find the sum. 18 plus 12 equals 30. So now we have our boundaries for x. X has to be between 6 and 30. Let's check it. We'll just pick something between 6 and 30 and see if it works, like 10. So 10, 12, and 18. We'll take the two smaller ones, add them together. 10 plus 12 equals 22, which is greater than 18, so we're good to go. Let's do one more. This is 1.5 feet and 5.5 feet. There's no triangle there, so we're going to start always by drawing a picture. You don't have to be really good at art to do this. We'll label the sides 1.5, 5.5, and the same process. So we've got, find the difference first. So 5.5 minus 1.5 equals 4. Then we'll find the sum. 1.5 plus 5.5 equals 7. So here are our boundaries. X has to be between 4 and 7. That is how the triangle inequality theorem works. Thanks for being here.